And then I started a company called Metadata Game Changers with Erin, my wife, who may be here soon. She's visiting a field station, which is really what she likes to do. So it may be that she won't show up. I don't know. But so we're really interested in helping repositories improve their metadata, understand and improve their metadata. And we do that. I'm a visual learner. So I look at repositories in different ways than the people that run them. And you all are invited to look at your repositories or someone else's repository in using these tools in the next hour and a half or so. So basically, we're going to give you some URLs, and you're going to like hack around on your metadata, look at your own metadata rather than me doing it myself. Do we want to do anything like an introduction? Would that be a good thing since we have such a small group? Do you like that idea? You can put yourself into the list, and if you want to, give a brief introduction, that would be great. Yes, no, good idea, bad idea? Okay. Natalie, you're on top.
I'm Natalie Rhea. My name is Natalie Rhea. I'm a research scientist at the University of Arizona. I work on a data repository called CSAR, which is a 20-plus-year-old NSF-funded sample repository for physical sample metadata. So anything from soils to rocks to water, we store information about those samples. We mint IGSN persistent identifiers, which are DataCite DOIs, and so we're interested broadly in improving our metadata and understanding how to better track our metrics.
We can go down the list. Yes.
I'm Mac Borazon. I'm a PhD student in information science at the University of Arizona, and I work with these two wonderful people. Something about data, something about yeah.
Hi, my name's Althea Marks. I am a data scientist at the University of Washington. I work with seafood trade data, and I have a few DOIs to my name, and I think they're all issued by DataCite. So just curious to learn more. In a past life, I did a fellowship that was tracing down data set citations through DOIs. So for the Arctic Data Center, but just curious to learn more and more depth about those systems. Yeah.
Who's that?
I think we're going around the room instead of down the list, which is fine.
Okay, my name is Martin Zoil. I work for Quasi, so work in hydrology. We run a repository called HydroShare. And as part of that, we're really trying to improve our metadata. And I spent some time this year to really work on improving our metadata as we switched from Crossref to DataCite. And the DataCite profile was way more suited to the data sets we're having. So we spend a lot of time really trying to improve what we have. So, but there's still room to grow.
Hi, everyone. My name is Emily Young. I'm a data manager at the Chesapeake Bay Program. So the Bay Program has some long-term monitoring data sets, water quality, benthic macroinvertebrates, phytoplankton, those kind of things. So I manage receiving data from the data providers and serving it out to the public. Not much thought has been put to the global metadata behind our data sets, so I'm really excited to figure out what comes up and what we need to work on just for bringing that up to speed.
Hey, Rebecca Ringett. If you know my name, I try not to talk too much. But I'm the senior open science scientist at the Heliophysics Digital Resource Library. You don't know us. We're heliophysics, but here to borrow good ideas because we face the same challenges as you. I'll leave it at that.
You can't leave these things out. Yeah.
I'm Terry Velikat from the Oak Ridge National Lab. I'm a data curator for some long-term projects there.
I'm Joshua Berkeback, also from Oak Ridge National Lab, and I'm more of a laboratory and field technical scientist who was voluntold to figure out a solution to our samples and sample archive management. So that's how I ended up here, was through the physical samples cluster.
I'm Andrea Thomer, Associate Professor at University of Arizona, and I work on the CSAR project with Natalie.
Okay.
Yes, hi. About repository? Okay. So, hi, everybody again. So, Nina from Agricultural Library of United States Department of Agriculture. It's the Ag Data Commons, the product and the repository and catalog of all USDA-funded data. So it's not only enterprise data, but also data which was produced through grants awarded by, say, National Institute of Food and Agriculture.
Okay. So we're going to talk about DataCite today. And does everybody sort of know what DataCite is? It's a repository for DOIs. It's a DOI minter. It's a registration agency for DOIs, so it mints DOIs. And it holds metadata for those DOIs, which is DataCite metadata. And DataCite metadata has, depending on what you count, somewhere between 80 and 100 or so fields. And some of those are different types for certain fields. So, but something, it's sort of a smallish metadata standard, and but it's big enough that if you're sitting there thinking, oh my God, 100 fields, that's so much, that's too much to work on. So that's true. So we divided it up into 4 different groups. That metadata can be used to serve a lot of different use cases. And so what we're going to talk about mostly today is the 4 fair use cases. So these are metadata fields that are in DataCite that are useful for either findability, accessibility, interoperability, or reusability. So there's 4 numbers there. And then 1 number is a combination of all those. So the combination of those 4 covers 61 DataCite elements. And this picture, which is in the notes, so if you're looking at the notes document, this picture is there. And on the x-axis in this picture are a number of records, up to 10,000. They're in DataCite. There's roughly, when I did this, there were about 3,600 repositories. And this is the fairness number, the fair completeness number for all 3,600 of them. So this is the sort of the definition of what the world looks like in terms of the whole data that we might deal with. Records on the x-axis and completeness on the y-axis. And what we're interested in is identifying bright spots. So bright spots are repositories that are doing well. And they can be defined on a bunch of different levels. So this is sort of the highest level that we might define them on, which is the total fairness. So it's the combination of those 4 fair use cases that I mentioned. And the purple line, which is in the middle, is the average, or the median actually in this case. So that median is about 24%. DataCite has a number of required fields, and if these repositories, they all have the required fields except for a couple stragglers that somehow got in early before those required fields were there. So there's basically a minimum of about 10 or 12% that everybody gets, and then the orange and green lines are the 25%. And the 75% quartiles. And there's a blog about bright spots at DataCite. There's a couple blogs, and I defined for the purposes of that blog, the bright spot level is 40%. So that's 2 standard deviations above the mean. And up on top, a few repositories are labeled, and these are repository IDs at DataCite. The most amazing metadata in DataCite is the University of Bath in Bath, UK. And their score is 61%. And you can see they stand out pretty far above the crowd. And then a couple of other bright spots. On the right side, these are, sometimes we're curious about whether doing good metadata is easier if you have less. So on the right side, these are all repositories that have more than 10,000 records. In this case, they're sampled 10,000 random records. And at the top of that pile is the Institute for Fusion Studies in Japan. They have 40 million DOIs, and they also have among very close, that little dot right at the top. These are 40 million DOIs that were created by a fusion experiment. So they're really like granules, like granular. Obviously, they don't have 40 million data sets, or maybe that's not obvious, but they don't have 40 million data sets. But then right below that, there's a little cluster that involves 2 repositories from the Czech Republic. They're both related to the archaeological map of the Czech Republic. And one of them is an IGSN repository, which is arch.igsn. And the other one is a repository of other archaeological stuff. So Bath and the archaeological map of the Czech Republic are really outstanding. In the middle, we have a couple other. BL is the British Library, so it's a large group of repositories, and we have Leeds and NERC. NERC is the National Environmental Research Council in the UK. So they're good. On the right is the Earth Observing Lab at UCAR, and there are a number of people here from UCAR. And they have been doing a recreation project over the last few years where you go back and improve your metadata, and they've really improved a lot. And then the other one, that CKO, is actually HydroShare, which Martin is here representing. And it's the difference in DataCite. DataCite hired a developer, and this happens with some of us. And that developer says, oh, you have these identifiers. You can't have semantics. No semantics allowed in your identifier. So that's why HydroShare, or Kawazi, is CKCODAXBBR. So Martin's goal for today is just to memorize that string. I have a couple of repositories in DataCite at Metadata Game Changers, and one of them is called SJYQ.OOZVIA, So anyway, that's what that is. And, Martin and I have been talking about this for a while, and it's really, he's got some great metadata that he's of course, he's modest about it, but he's doing a great job in terms of trying to get his content into DataCite. DataCite is not a primary metadata repository for the vast majority of these people. It's a repository that's created to get DOIs, first of all. And that's why so much of the metadata is only, or is close to the minimum, because it's called the give me a DOI as fast as possible use case. But so this is really not about, it's not questions about the completeness of the institutional, say, or the scientific repository that someone has. It's really a measure of how well they share. that metadata with the global community, because that's what DataCite is out there. It's open. It's a place for sharing. So it's also what we're talking about really is completeness. And some people use a terminology in this case called metadata quality, but metadata quality is really a big pile of stuff. Part of it is completeness, part of it is consistency, and then accuracy and other things that play into metadata quality are there. So I'm really focused on metadata completeness. So if I say metadata quality by mistake, which I might say, you can raise your hand and say, "Did you really mean that?" And I would say, "No, I didn't really mean that." Because from my point of view, you can only judge metadata quality by having users of data. And if those users of data get the metadata and understand the data that they got from you without calling you, then that's high quality metadata. That's my definition. No phone calls, high quality. Okay. Any questions, any statements, any disappointments?
Registering a lot of metadata with the data that also have discovery of how does Google and
I don't know. Do we have? Is anybody online?
Yeah, but for the recording.
Oh, for the recording. Sorry.
No problem. So my question was about adding metadata to registering it with DataCite. Does it help with discovery? So does Google index the information that comes from DataCite and in addition to what we do? So and how does it really relate?
How is
I'm just trying to figure out, is Google indexing the metadata directly from DataCite?
Do you want? Okay. Perfect.
Regard this as 85% true. So the way that Google performs internet searches is by the tags in your landing pages and the structured data that gets put there. So structured data is basically your schema.org aligned JSON LD. DataCite doesn't control what's embedded in the landing pages. That's the responsibility of the hosting institution, like Zenodo, for instance, or the repository. There is a conversion that DataCite enables through their APIs from schema.org to DataCite and back. There are big problems with that we're working on because their conversion from DataCite to schema.org actually creates invalid metadata, which means if you just use that, your page won't be indexed. So we don't do this really for the sake of discovery. We're mapping more metadata into here because for two reasons. I wanted our organization to get credit for the metadata that we're doing. And I don't want to write this kind of thing for our custom metadata system. Like, I need to sleep at night. But just plugging it into these external systems is one big gain.
Yeah, because we already do the schema.org and we do the mapping between the two. So that was maybe interesting to really figure out how that works. So yeah, I just wanted to know if there's an additional thing that will help us or not.
I think that, one of the things that's happening is there's sort of an evolution in the way that things are discovered. And we sort of went from discovering data sets at AGU and talking to our friends to using metadata in the web to find those data sets. And then we started using Google to find those data sets. And now I think what's happening is more and more, we're also discovering things through connections. And DataCite's really good at connections. And so identifying things that we'll talk about quite a bit and making sure that those connections exist, I think is, and I mentioned in this room in an earlier session, something called OpenAlex. OpenAlex and DataCite Commons are two large graphs that are using those identifiers to connect things to one another. OpenAlex, as of today, said they had 480 million things. So they're connecting data sets, mostly data sets from DataCite, and to journal articles from Crossref and journal articles from other places. And so whether you find something with Google is certainly an interesting question. And as Rebecca said, schema.org can be super helpful for that. But all connections between things like citations in scientific papers have been a way of discovering things. And now that's sort of happening with steroids. Okay, so if you can hit this URL, bit.ly repository tools, and hopefully you get something that looks like this. So if you got something that looks like this, then raise your hand. Or maybe hopefully if you didn't get something that looked like this, raise your hand. So this is the set of tools that I've been working on and with the help of my development team called Claude for the last few weeks. And one thing I wanted to talk about, we have a couple guides here. So the guides are the repository guides that you can get by clicking here, and I already did that. So this is a guide for how to use these tools as a data manager from a repository, and a set of steps that you might follow, and those might be useful in a couple minutes. DataCite has 66 consortia that are groups of repositories that are grouped together for some reason. And there's also a guide for consortia and maybe consortia leaders that want to help their members improve their metadata. So this is something and it has to do with the identification of those bright spots that we saw before, and using those bright spots. Those bright spots are at the center of a couple of ideas about organizational change. And so that's what the consortium guide is about, how to find those bright spots and how to use them. So now let's look at the tool, and we'll start out with the metadata completeness tool, which is here. So you can click on that. And this is the selection. So now you get to select your repository. So some of you may know a repository ID or a repository name, or see if I can remember this. There's a link here in the notes. Where did it go? Joe, down or up? Pardon?
Keep going.
Yeah. So repositories.xlsx is a spreadsheet that has in it repositories. These are repositories that are related to ESIP. At the top is Ag Data Commons, which is a great repository that Nino has. This is the archaeological map of the Czech Republic. So if you want to see what some great metadata looks like, that's a good example. But there's a bunch of repositories here. And so if you don't, this ID here, Cornell Library.library or DOE.int or DOE.asti, or DOE.ornal. These are the IDs that you want to put in right here. And you can also put in things like California, maybe. You can put in names of things, and it'll do a search for you. So if you want to look at a repository that's not on that list or explore something, you can do that here. And I'll pick something. I'm sorry, I'm a little bit challenged on this computer. Come on, guys. I'm trying to select this. We'll just do this. I'm going to look at nkn.nkn. There are other selections that you can make here. For instance, DataCite has a lot of different kinds of resources. Most of them are either data sites or data sets or text. So you can use this to select one of those. These are all the different kinds of things that DataCite has. You can also use a query in the DataCite API. And there's a little note down here for what those look like. I mean, these are more advanced things. And then here is the number of records. So if the number of records 200, the default is below, smaller than your repository, then it'll just do a random sample of 200. So that's sort of quick, and it usually the random samples are pretty representative. The average, the median size of a repository in DataCite is just less than 200 records, believe it or not. The largest one we already mentioned is 40 million. The second largest one is Disco, which is another sample repository for museums in Europe, 14 million or so, I think. And then things like Zenodo that you probably heard of, sort of 8 million kind of numbers. So there are some really big ones, but most of them are small universities or all kinds of different organizations. My company, Metadata Game Changers, is strongly in there with 32 metadata records. So we're sort of small. But so that's why we put in 200 here, because for half of the repositories, that'll get everything. And then we hit this. You can also put in here a single DOI. One thing, it went away. You can put it in a single DOI. So if you want to look at a single DOI, you can also do that for some reason. Okay, so did everybody get a repository and get a result? But it's on spreadsheet. How do I find the? What's the name of it? The knowledge. Try putting in knowledge. Do we get anything for knowledge? I tell you, I'm getting. This one of the things that Claude didn't actually do very well is this. Is there another repository that we might be more lucky at finding the knowledge? Oh, yeah. Okay. Arctic Data Center is in the spreadsheet. It's a little bit special because it's actually in a CDL repository. So the repository is cdl.ucsb. And then down here in this query, you put prefix, colon, and then the prefix that's in the spreadsheet under Arctic Data Center without a space. There may be a space in that spreadsheet. Did you find that? That's an interesting one, actually. And yeah, so you need to, because of the way that the California Digital Library does their repositories, DataCite has a prefix that goes on the front of a DOI, and CDL within that cdl.ucsb repository, it's got basically about 12 different prefixes for 12 different groups. And actually all of those are supplied by the Arctic Data Center. But so it's Arctic Data Center and a bunch of other ones. So if you find their prefix, you'll get their metadata. Okay, everybody else got something to look at? Okay, so this is the something knowledge network. This is also a knowledge thing, but this is at the University of Idaho, and I happen to pick them because I know them and they have some good metadata. So I mentioned that there are 4 different use cases, 4 different FAIR use cases, which are here. The first one is text. The second one is identifiers. The third is connections. And the fourth is contacts. There's some other options that'll come up, but we're just going to deal with those right now. And for the first one, which is FAIR text, around this radar plot are a bunch of different elements in in the DataCite metadata schema. There are actually concepts, documentation concepts that are represented in that schema. And then zero, if zero records have that thing, or 100% of them, it goes from the middle to the outside. Okay, so this is a radar plot. Is everybody seeing something like that? Okay, and then over here on this pile, or in this text table, are the fields that are included in that. And if we want to look at, see like who are the authors, we can click here on resource author, and it shows us a list of the authors. So a lot of times repositories have a few authors. This one's not that many, but they might have 4 or 5 authors that have a lot of records. And so maybe you might have an author with 100 out of a 300 or something. In this case, Donna Del Parte has 21, 4% of all the records. And this is sort of a quick way to take a look and see what kind of things are in this repository. So you guys can look around at your repositories. Resource type general is something. I mentioned that DataCite has a lot of different resource type generals. So for the samples, for ITSNs, these would be physical objects. But so this is a way of looking at the content of your. I mentioned that we look at repositories in different ways. Usually people look at repositories like this, one data set, say one record, and they look at that record. We look at things through the columns, the different elements, the metadata elements, because we're interested in consistency of those elements. And up here we have the score. 72%, which is great for text. Over here are the required fields. Most of the required fields are here. So they're in all repositories, and they get you to about 40%. And then the second use case is identifiers. And so these are things like RORs for organizations, or ORCIDs for people, or RORs for funders, or various kinds of identifiers. Identifiers are important. And again, a radar plot and the opportunity to look at certain, sorry, this computer is just a little bit strange for me. But so there's things here like ORCID IDs for resource author. And so these are the ORCIDs that are in this repository. And you can copy these and paste them into a spreadsheet, or you can save them as a CSV. Connections, a few things in connections. When DataCite connects to something, you get a chance to tell what that thing is and what the relationship is. And resource format and resource size also ended up here. So if you want to see what the formats are in this repository, you can see they have a bunch of images, TIFFs. Okay, so that's one thing that we can look at. Any questions here? Any surprises? Sometimes people see surprises here. Nino saw a surprise the other day because, what did we look at? Publisher. And she was surprised to see the publishers in her repository. In this case, these are the most of the publishers of the University of Idaho. So this gives you the first sort of look. Anybody finding something funny or unexpected? No? Okay.
Thanks. Before you shift off of these plots, one of the things that reporting...
Speak right into it.
I'll eat it. How's that?
There we go.
Okay. One of the things that people that request reports like to see is what's our score for F, what's our score for A, I, R, right? And then what's the total score? So this is separated a little bit differently. And I know you had it a little different in the past. how do these 4 categories connect to the 4 letters of FAIR?
Okay. Originally, these had the names of F essential and F supporting. So really, these first 2 are like Fs for findable. We saw in the text one things like author names, things like award titles, things like resource titles, things that are text. So this is really the target for what Martin was asked about, sort of Google full text searchy kind of things. And then identifiers are really the target for connections between things in graphs, things like that, mostly identifiers for people and organizations. So the first 2 are really F, and then the second one, the last 2 are really AI and R. DataCite was created mostly with discovery in mind, so most of the content in DataCite is related to discovery in some way. So the AI and R are actually rarer. There's fewer things in the repository, so and they're used much less often. So AI and R are out here, and you can say putting the air in fair, which is something I sort of like to say. But these 2 here are really F in 2 different ways, and then AI and R. That's why things like format ended up in connections and size ended up in connections, because they're sort of they're related to interoperability and or access, maybe size. But so there are a few funny things. So usually I look at the total scores, mostly like in that field, the figure that we did, because the total scores aren't necessarily anchored into FAI and R. Okay, everybody cool? How you doing, Mac? The repository IDs came from DataCite.
I was repeating the question, where the repository IDs come from.
Not really a comment. I mean, it is a comment, not necessarily about finding anything weird, but what I'm observing. So for CSAR, the DataCite schema is a terrible fit for our metadata. The crosswalk from IGSN. So for those of you that don't know, CSAR is a repository of metadata records describing physical samples. So rocks, fossils, whatever. The DataCite schema is terrible for it. It wants everything to have a title. What's the title of a rock? And so there's a lot of really awkward crosswalks in there. So we have a relatively low FAIR score. I think it's, 24%.
That's average.
Yeah. And part of that's just because we don't bother trying to crosswalk things to stuff that doesn't make sense. Like for keywords, we're using, we mapped the object type to keyword because that was the closest we could get. We do not have a URI for the keyword vocabulary. Okay. So I guess I get the comment is really, I wonder if you were to do, it would be interesting to see how this changes across object types, depending on how good or bad the DataCite metadata schema is of a fit for what they are. I imagine it's better for preprints. If I were to hypothesize, I would say it would be better on average for things that are documents and get worse. I wonder if it would get worse the further away from document likeness it would go. So,
maybe one of you guys from IGSN land could look at arch.igsn, which is the archaeological map of the Czech Republic, and it has the best metadata for any the most complete metadata for any IGSN. So it would be interesting to see what decisions they might have made about those crosswalks. ARCH. Yes. .igsn, I think. Yeah. Obviously, and I've looked at, thousands of repositories with these numbers, and I have yet to see sort of a dependency on type. In DataCite, most repositories, the most common things are text and dataset. But yeah, that's one of the things that we can do with this tool is make comparisons in a single repository across different types. Or, in Metadata Game Changers, we have a lot of blog posts that are about like, what does project metadata look like across all of DataCite? And so, or instrument metadata, which you can also do in DataCite. So these questions about how these might vary across different types is a super interesting one that is you can take a look at here. My sort of anecdotal evidence there is I haven't seen much evidence for differences, and most of that is because most of DataCite is focused on the mandatory fields, and those title is an interesting one. It could be my favorite rock, or my favorite rock 2, or my favorite rock 37. But anyway, so that's an interesting thing. Other questions or comments? Okay, there are a couple. Oh, sorry.
I even have the mic already. It's dangerous. Waiting patiently. But one of the things, just sharing an experience with you, like one of the things that we're using this for is we're in the middle of a redesign for our international metadata standard in heliophysics. So we're using some of this as input into what that new standard needs to support. But there's a scope boundary. Just because it's in DataCite doesn't mean it's relevant for heliophysics data sets, right? We don't need to indicate all the different roles that were highlighted and stuff like that. But on the other side, it'd be great to have publisher identifiers because that's a thing these days, right? So this kind of representation could prod changes into metadata schemas, but my advice is keep the brain attached, make common sense decisions right before you put yourself into a spiral of theoretical completeness. That's our perspective.
One other thing about DataCite is that it's never meant to be the total metadata solution for somebody. So more specific scientific metadata is something that is also many of us have in many different ways. If we look at connections are kinds of connections, and connections are super important to me onto DataCite. And one of them has metadata. This is my favorite element. And you get to connections just by clicking on this purple thing. And so has metadata is a pointer back to your original metadata that could be more detailed scientific metadata. And I have a couple talks and probably a few blog posts or something about it. But so has metadata is something that might also be helpful if you have scientific metadata you want to point back to. And DataCite also allows you to put in the schema for that metadata at the same time. And so I mentioned that there's a couple other groups of things, and they're sort of up here along the top. So one of the things I also said was that the connections are really important. And also in projects or in other things, the kinds of contributors might be really important that aren't just creators. So if you click extras up here, these guys aren't doing very well here, but there's two spirals. This one's 0, that show you all the different kinds of relations that are sitting over here now. These are the kinds of relations, and has metadata is one, and is metadata 4 is another. Most of these occur in pairs. And then there's also the DataCite contributors spiral, which has all the different kinds of contributors that can be identified in DataCite metadata. So if you had a student or a librarian or yourself that was interested in thinking about the contributors to creating data sets or collecting data sets is collected by Oh, data collector. Sorry. That might be something that would be relevant for a sample. And so the FAIR ones are sort of general and cover a pretty broad collection of things. But these other, if you're interested specifically in contributors or relations, those two are also here. And then there's also DataCite can be used for project metadata, and that's something that Aaron and I are interested in. And so there's 3 different project use cases. One is project members. And this is where contributors also come in down here, different kinds of contributors and their identifiers and stuff. And then items that might be connected to projects and relations between things in projects. So those are sort of the three different main groups. There's also an NIH thing in here called share, but we won't get into that. And storing things and sharing them with your friends is really important. So when you find out that your metadata, maybe when you improve them in some way, there's a little strip here, which gives you the strip of all the pictures for whatever the things are. The use cases are, if you're looking at FAIR, there are these 4, and you can copy this and paste it into email and send it to your parents and stuff like that. Look at this metadata. Wow. Okay, so any other questions or did anybody find something funny in their metadata? No? Yeah. We found something funny in Rebecca's metadata. She blames it on spades. That's her go-to blame target.
Tell story.
I think so. Joe wants to hear.
So a big chunk of our problems come from curation practices, of course, right? So the most irritating one is they had a convention of putting all of the authors in a single field, separated by commas or semicolons, or maybe both. So there's only so much scripting you can do to correct that without diving in by hand. So some of that apparently didn't get corrected and got piped into DataCite. So now we have apparently an author that has an ampersand in front of his name. And there's like a string of organizations as affiliations. I could go on. So it's not all space, I will say that. Yeah. Some of it's just the bad practices, right? But here I am thinking like, we corrected this. We're good. And I'm just scrolling through the random stuff he was scrolling and I'm just watching. Like, what? It's still there. So it's like even just scrolling by, it was useful. Now, it would be cool if there was some sort of tool that, just thinking about it out loud, I guess, if there was some sort of tool to say, hey, you're sure you wanted this ampersand? Or, hey, you have commas in the author name? It's like some sort of flagging system maybe in the interface. I shot so many ideas at him earlier.
Anything else? What do you think? Interesting, Natalie. Did you find anything?
Specific insight right now, but it's yeah.
Martin's metadata is also really good. I already said that, but
no, I think.
Yeah, okay.
So what I see here is nice, it's good, but it's expected where we have gaps, especially on the connection side. So that's something where we have not been really good, although we have data in our database, but it's not exposed. So I think that's maybe what other people have. There's a lot of more metadata available, but it's not necessarily exposed or pushed to a data site.
Yeah.
So that's what we have tried, really looking what we have and make a push and then go back and the next level. Okay, now we look at connections, how that could work. So, no, I think it's expected. So, yeah, nothing that I thought was really too surprising.
You're good. Well, it's always nice to find some surprise. How about Ellen? Did you find something to look at?
Yeah, clearly our data set is not there, but I knew that anyway. I was just cruising through EPA's data set. It's the most sort of relevant one for me. And I'm just interested in what fields do pop up and what's there. It's just stimulating ideas for how we're going to move forward with our data sets. So nothing wild or surprising. I found no ampersands yet.
And Althea, how about you? Anything in the Arctic Data Center?
Located outside.
Uh-oh.
Thank you. I wasn't able to locate it outside of just UC Santa Barbara, but I think I missed your instructions.
Okay.
But that's okay. I looked at my most recent data publication, and it's it's a solid 7%. But this is interesting because I literally yesterday in a lightning talk, I guess it was in this room, I had my FAIR assessment generated from the repository that I used, and they have a assessment of the EML metadata.
Arctic Data Center assessment?
Yes. I mean, they're sister repositories under Data One. But so, and they break down, and I don't know the behind the scenes how they generate that assessment, but it's based on the ecological metadata schema, which is used by the repository. So yeah, I guess this is more of a fundamental question and just like gap in my understanding of this system. But so that metadata schema, in order for it needs to translate to the DataCite metadata schema. And so like if there's not a nice mapping between the two, that's reflected obviously or is it reflected, I guess, or how does that mapping between the two work? Which, yeah.
Well, the scheme that the Arctic Data Center or Data One are using was actually developed in the same NSF project that this was developed.
Oh, okay.
And Matt sort of stayed with EML and ISO and schema.org, and I sort of started doing DataCite. So a lot of the lineage, the grandparents of this project are the same. I guess it's me and Matt. So, but that was why these names are like resource author rather than creator.name or something. So what can get translated? And actually, I'm working on something now with Matt, sort of starting to look at Data One through, or looking at Data One through the DataCite lens, and it has to do with that sharing thing. And that sharing thing is made up of how much you want to share. Like, are you a shareful person? Or how much can you translate? And that sort of goes back to the IGSN thing. So both of those things play in. And the Data One suites, what I call use cases, they call sort of suites. And they include some other stuff about they have something about the length of the title, and so they're trying to get a little bit more towards that metadata quality thing in a small step in that direction. And so it's interesting to compare them.
To add to that, we did both. So we also have a project with Matt to really, because we also data one node. So, and use schema.org. So inside of our landing pages. So both of them, we compared both of them. And the mapping between the different words is different. So if you're good for DataCite, doesn't mean you're good for the metadata dig test that they have. And that's because it's just not meant to be, they just have different vocabularies they use for testing. So, when you post it, they're just very different dialects of the same thing. So that's why you can't really compare them. They have different purposes. So that's we try them both. So we are trying to do both. So essentially, put a decent amount of metadata into a DataCite, but in addition, have a more expressive schema.org record as well that metadata and could find as well. So trying to do as best as we can. Yeah, so they're somewhat complementary and very different use case.
The interesting thing that I found is I looked up the DOE Oak Ridge National Lab. I saw it listed on there, but I'm not sure what repository that is at the lab. And it's just pulling what, 200? Is that the amount that pulls in?
Right.
And I don't know what. Maybe I'll recognize something. So I'm wondering, so this is from the ORNL repository. Where is that in DataCite? Which field is that in DataCite? Who attributes that to
You
the?
can look under the publisher in the text.
Okay.
It could be there. I mean, I don't know where the people from, I mean, I sort of know publisher's sort of a funny field, but it is required. So if you looked at in the text use case, and there's a thing called publisher, resource publisher, I think it's called, and that would show you maybe where more detail about where it's coming from in ORNL or I don't know how. I just made a list of things from ORNL. I don't know what they all point to. I mean, I sort of know about OSTI to some extent, but those other ones I'm not so sure about. I'm not answering your question, I don't think.
Yeah, I'm just curious the flow as to how they got tagged as a ORNL repository.
But I don't know.
Yeah. And I've been talking to OSTI about how things are attributed in there, because for the projects I have, we send them to repository ESS Dive, and then they send that to OSTI. And so I'm limited by whatever fields my repository has that then goes into OSTI, that then shows up. So there are fields I know that I would like to use, but I can't.
Yeah, well, we call that the metadata telephone game. So someone starts with a metadata record and it goes to someone else and it goes to someone else, and for various reasons about mappings or what people care about, those things change. And this is one of the differences between DataCite and Crossref. So Crossref is very similar to DataCite in terms of making DOIs, but it has a journal in the middle between the author, the scientist, and Crossref, because the journal actually controls that metadata. Or in the CDL case, in the UCS, in the ORNL case, OSTI is between a lot of people and their metadata. And so, yeah, the policies of OSTI and those could change as a function of time. So one of the ideas we have here is if you have more metadata that you think should be showing up in DataCite, you could take this tool to OSTI and say, hey, like, what happened? We're giving you this. Why aren't you sharing it with DataCite? And they'll say it's going to be in the next version or something like that. And you mean ESS Dive? Yeah. Okay. I mean, yeah, whatever. So one of the things that we like about DataCite for us is that we control the metadata, and we can fix it, and we can improve it. But in a lot of universities, you know, the researchers are somewhere in the library somewhere, and the library talks to DataCite. So yeah, there's a lot of situations where metadata makes multiple steps. Those are called data journeys. And the organizations that are involved in those journeys also affect them. So yeah, I mean, and special cases, you know, it's not really special cases, it's just the way things work in a lot of organizations. I mean, I've had a lot of discussions with librarians who do very limited things in terms of giving things to metadata, to DataCite, and that's why in that original picture, the average is so low. I mean, you start at 10 and the average is 23. So, you know, a lot of that is because of the focus that DataCite has had on identification and citation since the beginning. And many of the libraries are still using the tools sort of from the beginning. So all they get is the required fields, for instance. But so, you know, those situations are special. I mean, they're all different depending, it depends, you know. So, but well, yeah, we could talk about that. But then we might get in trouble. So one other thing that's interesting that maybe we'll take a look at just sort of quickly because it's a little related to this. If you there's a bunch of different tools that are involved in this business. And so if you go up to the top here and there's something called repository history and you click on that, these tools, and here's a tip when the tools are retrieving things or something's going on, it shows you metadata tips. So you have something to read while it's doing a retrieval. But here what it did is it looked at this nkn.nkn, and it turns out that there are data in there from 2013 to 2026, and it retrieved those records every year. And so what this are the same use cases that we were just talking about, but it's showing them every year. So if your repository changes practices, or if your OSTI, you know, the group that's between you and DataCite changes policies, then that can affect the completeness of the metadata. And in this case, we can see that they had sort of looked sort of stable up until 2019, and then there was an increase. They have this repository doesn't have many records. In fact, some people might say they've got hardly any records, but we can see the data here for this yearly thing going from 15, 17, 23, then up to 48, 49. So this is a situation where a repository became a bright spot because they changed their mechanism for creating the metadata, or something changed in their behavior, and that shows up. And I did a blog post a while ago about finding repositories. This is how I found NKN. Do any of you know Luke Scheneman? His picture showed up somewhere at this meeting. But anyway, he's the director of this group, and it's cool to see that they had an increase. And when we get Arctic Data Center working, Arctic Data Center, you can also see some changes in the behavior of the repository over time that improved their metadata. And of course, Matt likes that, and I like that.
So for the yearly plot, is it showing basically the initial state of the DOI metadata created that year?
No.
I missed it again. What is this?
And it says that every point scores a sample of the records registered in those years as those records are today. So the answer to your question is in the first line of the documentation, which is great. And we talked about this earlier, but yeah, you can change this to the updated date. So if these records were updated at some different time, then you can look at when they were updated. But we're not yet doing the time machine going back. It's possible. But I mean, you know that there's a lot of activities in a lot of these repositories. So if you start trying to take 5,000 records and time machine them back, 10 years, it's going to take a long time, but it is an interesting question.
Sorry, the year on the plot is the registration year, but the state is the current state. Am I getting that right?
Yeah.
Hopefully it sticks that way.
And that's going to become more of a problem as more repositories start updating their metadata. The fact is that usually the registered date and the last updated date are the same. So for a lot of repositories in DataCite, this question doesn't exist, or there's the answer is they're the same. But I have an example, which is iris.iris. So some of you probably maybe know about the National Geophysical Facility, which is an NSF facility, and IRIS is a repository of something that used to be called the Institutional Research, Incorporated Research Institutes for Seismology. And in that case, we updated 117,000 metadata records throughout the entire repository in 2025. And so the plot for registered year and update year are very different. Okay, so there are some situations and they're sort of special, but maybe there'll be more.
Question about, we are allowing every author to change and add metadata for certain things. So we are keeping the author and the title and the content immutable. But if people add another contributor that I forgot, or if they have a different citation that they want to add, or update the funder, they can do that, and that automatically updates the DataCite record.
Great.
Is that a good process?
Is that what?
Is that a good process? Is that what we should do?
It sounds good to me.
Okay.
There's so in these tools, where I want to be conscious of time here. There's something called connectivity, and so I'm going to just look at connectivity. I'm going to try and actually, what I'll do is, instead of repository history, you can also look at repository activity. So repository activity, it remembers the repository you're looking at. And this shows changes that have happened to those records. So this will be interesting to look at for HydroShare. Changes to those records that have occurred over time. And so for a situation like Martin just mentioned, where users are updating their metadata, this is something that would be interesting. And in each of these stacks, it's the things that are, the colors are the things that changed. So in the second quarter of, or the third quarter of 2025, these guys they changed their URLs in a bunch of records. And they also changed the schema. They probably went from 3 to 4. And if you click on this, it shows a sample of the DOIs that changed at that time. And if you click on one of the DOIs, then it shows you, and you scroll down, it shows you a timeline of when those changes were made and what changed at what times. And then the actual diffs are shown down here a little bit lower. So in this case, the URL changed from data.nkn.uidaho.edu to verso.uidaho.edu, and the schema changed from not being specified to being 4. So in a situation like you're talking about, Martin, where things are changing in your repository and you want to see what those are and when they happened, then that's what this, there's a couple of views of that. And this is the sort of long-term view that you can take a look at.
We switched from Crossref to DataCite. I know everything is registered this year.
Is what?
Is registered for this year.
Oh, okay.
So we don't have any history. Is that expected?
You have a short history.
Yeah, it's only for only for this year because we moved from Crossref to DataCite last year.
So we don't have we could do this of putting the published date. There is also a publication date. We could put that in here, but publication date is sort of a can of worms in other situations, because in some cases the publication dates people gave DOIs to something 20 years after it was published, old papers, old data sets, so publication date goes back long, in many cases, long before DataCite was formed. So when you start looking, and that's why we have registered date. So your situation where you brought everything in, that's sort of a special case again. There may not be a lot of people that are in that same environment. There could be, though. I mean, there's a lot of things where you see more activity at the beginning. In fact, if we go back to the repository history in this case, I think for NKN, and there was another one I was looking at, but these guys had a burst of activity in 21 to 23. And so, yeah, so you've got a special case, and we could do published, but it's a funny date. And the registered date, I mean, the reason that we started with the registered date is because this is really a tool for looking at repository behaviors and trying to see changes in those behaviors. And for Iris, for instance, where we updated the whole repository, basically, that their history is very flat. There's a blog post that's being written right now about this. Their history is very flat at a high level, but if you looked at their history 2 years ago, it was very flat at a very low level. So it's called the raising all boats model of repository change, where everything went up, and that's why you can in all of these situations you can save this data and you can make snapshots of what it looks like when you did something, and then compare later when something gets approved or improved. Okay, so if we go back to metadata completeness, one other thing I wanted to talk a little bit about is sharing with metadata connectivity. So connectivity is a little bit different than completeness. Connectivity is how many identifiers are there in places where identifiers can exist. In other words, if you have an author that happens 20 times, how many of those 20 times do they have their identifier, their ORCID? Because we'd obviously like it to be 100%. But so when you click on connectivity, it's sort of divided into groups based on things that can be identified and how many identifiers they have. So in this case, how many identifiers do creators have? The ones that are green are creators that have all of their identifiers. They're complete. The ones that are red, the ones that are red are creators that don't have any identifiers. And the ones in the middle, the yellow ones, are quick wins. They have some of their identifiers. So when we click here, we can see that Frank Wilhelm occurs 4 times, but only has his ORCID once. So there are 3 quick wins here because you already know this identifier for this person. You just need to spread it out into your metadata. And the same for Sanford Eigenbrode and Daniel Thornton. So these are quick wins, and there's some number of them here, maybe around 10 or so, which is sort of smallest. But remember, these guys don't have many records. And then the red ones are creators that don't have any identifiers. And then there's down here somewhere at the bottom, there's the creators that are the good ones that already have all of their identifiers. And some of these creators can be organizations or they can be people. And so in this case, you have a button up here that says Find RORs. RORs are organizational identifiers. So for the organizations that don't have all of their identifiers, you can look up their RORs here. Oh, and then you can search ROR to take a look at them. Didn't mean to do that. But so for Idaho EPSCoR, in this case, these RORs are probably not very good because that's sort of a funny name, but Idaho Wheat Commission, this isn't a great example for this one because it doesn't actually look like any of these are right. So you can, in this case, not mark any of them as valid because none of them are valid. We can go back, and also this will be a little bit longer. Finding orchids. So this is another opportunity to read your metadata tips that are going to go by here while the tool is looking for orchids for you. And we're searching the ORCID API for these names. And this is searching for orchids using names is a tricky thing. In some cases, like we saw Sanford Eigenbroda, that name only occurs once in ORCID. So we think that that could be right. Or a writer, or more correct than maybe Frank Wilhelm, there are 3 different Franks in ORCID. And so here it gives you the most recent employment that person had. And then it also gives you the journal article or the journal in which their most recent article occurred. So because we're looking at the University of Idaho, it's likely that this first Frank is actually the right one. So then you can mark this as valid. And then when you save this as a CSV, that valid column is true. And you can then use that as a source for orchids to connect to people in your metadata. Okay. So that's a little bit about connectivity. And we do that for orchids. We also do that for creator affiliations. We do it for creator affiliation identifiers, and then the same thing for contributors, and the same thing for funders. So funders look pretty good here. There's 29 funders that happened 207 times. We can take a look here and see which of those funders are identified and which are not. Funders like to use these kinds of metadata to find impact, so having their identifiers are good. And again, RORs are being used to identify funders. So we can maybe do better in ROR land with these names. Dovetail Genomics. We got Dovetail Genomics. Forest Research, again, Idaho, some of these are obvious things that only happen once. And where the name that we're searching for is the same, and some of them these are actually quick wins. So if these are right, then you can use them in the metadata. Questions? Let's go back here. Oh, one other thing. Who was it that had the question? Was it you again? Oh, yeah, okay.
I have lots of questions. But one of the things with funders is that some of them have DOIs and not RORs. Is that...
Some of them have DOIs? Oh,
yeah.
They have Crossref.
Yeah, Crossref DOIs. How would that be incorporated?
If the funders have Crossref or FundRef, is sort of the name they like, identifiers, then they would come up as having an identifier. But because we're also moving to RORs, we're searching for RORs here instead of Crossref funder IDs. But because there's content in that field, we're not doing anything looking at the structure of that field to see if it's a valid ROR or a valid DOI. So we would count those as existing. And the process of going from Crossref funder IDs to RORs is something that we could sort of work on inside of here somewhere to try and, if a repository said, well, that's what we're trying to do there. So the problem is that there's millions of Crossref funder IDs out there. and they decided to abandon that idea. They're not going to do it anymore. So now they're sort of transitioning to ROAR. So in the best case, you probably have both of them. But it would show up as being identified. In the connectivity, one other thing we're going to blow through here. Down at the bottom, we're looking at names and trying to find matching names with some fuzzy matching, and trying to give you an opportunity to try and look at multiple names that have the same identifier, or in some cases, in this case, these are two spellings of Ernest's name, and in a lot of these are just first last versus last first, or initials, and they show you all of the ways that different representations of names cause problems. And in a lot of some of those cases, like this one, Benjamin has an ORCID for one representation, but not for another. So if you're trying to get ORCIDs into your metadata, and then you need to account for both of these representations of names. And in some cases, not in this repository, but maybe in the ones that you're looking at, there's interesting things where there are problems where, one, maybe an ORCID, if you have a group of authors, maybe an ORCID for one gets mistaken for another person, and that person ends up with two ORCIDs. In those cases, it gives you links, like down here, to the records that you need to fix to correct those errors. And these guys are doing pretty well in terms of consistent names. Usually for even sort of random repositories that get picked, you end up with some problems there. Whew. That was a not so quick tour. But questions or answers or suggestions, if something comes to you in the middle of the night, I have an email that you can find, ted@metadatagamechangers.com.
You said the word suggestion.
The what?
You said the word suggestion.
I said the word projection. I'm sorry.
I have a suggestion. I'll put it that way.
I got these things in here, but they're not working very well. Okay, suggestion. Yeah, I like.
So you saw earlier, we got problems with affiliation names, and even in some cases, like the ampersand example, the person names just getting mashed up with the coding. Is there a way to what do you think about a way to click on it, change it, or like have a new row be the correct thing, and that be have that be clicked valid, so that when we download it and feed it through scripts, we can do an auto replacement for all the things in that group? I think the face says that's too hard.
Yeah, I think that's a great idea.
Okay.
Did someone say it was too hard? My face? Well, it's always better than saying it's easy and then having it turn out being hard. So you might as well start out with it being hard. One of the things that like these names, last comma first and first comma last, it would be easy to build a tool that said, fix that everywhere. I really like first last. Some people, this is something that people can argue about, believe it or not, for a long time. Should it be last comma first or first last? People like to argue about things like that. I sort of like first last, but then people say, I want to sort by the last name. And then you say, that's too bad. How about sorting by the first name? But yeah, the idea of having picking valid names. The problem is that in a lot of these the situation is, in some of these cases, we run into two ORCIDs for the same name, and or two names for the same ORCID more often. you've got someone whose orchid it is, and then you've got someone else's name who also has that orchid somewhere. So the number of kinds of messed up things that can happen, like that one affiliation that you've got with, 20 different universities in it. I mean, to make something that the diversity, like, is this roar right or is this orchid right? That's a simple one kind of a question. But in this section, it's fuzzy matching for one thing, and there's a lot of different problems could exist. So, I would be a little bit nervous about trying, because as soon as you try and do one, then someone else is going to call you, and it could actually be the same person in some cases, and they could say, well, now I want it to do this. And here's this special one, and I want 2 buttons. And if I have one button that says flip these names, and So I'd be worried about the diversity of kinds of problems that we can run into here.
Well, the idea was to have a way. No. Like add a row in that same fuzzy matching thing, and actually, assuming it's all crap, because that happens sometimes, they can type what the right answer is, and then copy the right orchid to be there, and then that one's valid.
Okay. Yeah, I'll think about it. I wish I had an example. I mean, almost even Amanda French, who is the technical community leader for ROAR, had the wrong orchid for herself in a DataCite repository for ROAR. So almost always there's some problem with orchids. But I picked a repository. Did anyone else find? You guys probably have problems with orchids in CSAR. Yeah.
Natalie, do you want to?
Now, today in 2026, we're using Orchid exclusively for login to CSAR.
Yeah, that's
but
great.
Prior to that, there was a bespoke login option too, and so we have some temporal differences in how populated orchids are in our records.
Yeah.
Were you going to say something else? Okay.
Yeah, using orchids to log in is a great thing for consistency.
Yeah, and for us, then it made it so we didn't have to maintain this other bespoke thing. Yeah.
Well, when we recurate CSAR, and there could be orchid problems in the past.
Well,
And then you could show and say, this is what a great job we did because we're now using orchids to log in.
Yeah, like that will work for users. And the challenge is it works for users. It doesn't work for like all data contributors, because many collections have very old legacy specimens from before orchids existed and people that have since passed on. So there's things that we're never going to get very high rankings on for providing identifiers. So just because of the nature of the data. And there have been attempts to add identifiers to historical collector names in the biodiversity community, but those were mostly funded through volunteer work, and those people need to retire and can't afford to maintain their databases. So.
Any other comments? How does the Orno group feel about this? Interesting, helpful, potentially helpful, maybe.
I can see. I mean, on the flip, there may be easier ways to find where things are written differently, because I just saw Oak Ridge National Lab and Oak Ridge National Laboratory, and there's like a third of them are one way and another. And then I did find, Joshua found records that look familiar inside. Just needed to add more and do some more searches. But yeah, this looks helpful.
Great.
Just out of curiosity, going through, do you have, obviously you have your metadata completedness But then in a lot of those, I might click on something to some URL links and I tried pasting them in and they were dead links. Is there any plan to sort of correctness or take it a step from is there something in this field to is there something useful in this field?
I mentioned the relationship between this and Data One, and Matt Jones, who's the director of Data One now, and I have been working on this for a long time. We just talked about this the other day. Or like form of orchids or form of roars, are these valid sort of link checking stuff? Those are all possibilities. It's amazing in that actually in orchid land, I'm sort of amazed by how few incorrectly formed orchids I run into, which is sort of surprising. And it could be because people are using it to log in. But oh yeah, we're out of time. Cool. Thank you for coming. If you have other questions in the future, let me know. And if it was helpful, let me know.